Hello again. Today we're going to be covering another powerful concept that is frequently used within programming. This is something that many of you have probably accidentally already stumbled on, but may have not actually ended up using within your final projects or your final source code. The concept I'm talking about is referred to as recursion. At the 25 million foot view, recursion is simply what happens when a method calls itself as a function. We'll get into that more later. In order for you to understand this concept, in order for me to explain it better, I'm going to be using both loops and comparing them with actual recursion to make a program that prints out the Fibonacci sequence. If you don't know what that is, well, let me look that up first. So the Fibonacci sequence is what happens when you take numbers starting with either 1 and 1 or 0 and 1. This is the one that we'll be working with. And add up the current number and the number after that to get the next number in the sequence. So 0, we add 0 to 1 to get 1. For 2, we add 1 with 1 to get 2. 1 plus 2 is 3. 2 plus 3 is 5. And it goes on and on and on. Really simple concept. I mean, you can look it up if you're having a hard time understanding that. So the idea here is to print off the numbers in the sequence until we get to a predetermined maximum number. And we don't want to print higher than that maximum number. So let's get started with the loop version. This is something that maybe most of you would write initially, if you didn't know about recursion. So we're going to create a void method named Fibonacci Loop. Oh. And we'll have it take in our maximum. This is the number that we don't want to print higher than. We will have our current int, which is the int that we are printing off. We'll call it cur. C-U-R-R. I'm bad at typing. Then we'll have our next int, which we'll just call next, and we'll set that to 1. So this is the initial state of the function. Now we'll get into our loop. So obviously, because we don't want to print more than our maximum number, we will say while cur is less than max, we'll do the stuff in our loop, and we will see out our current, followed by a space so that we can differentiate between numbers that have multiple digits and single-digit numbers. We will also create a temporary variable because we'll need the old value of current. We're going to replace our current value with our next value, and then set our next value equal to itself plus the temporary value that we just set. So this looks to be correct. Let's try it. Rather than printing hello world out, we will run our Fibonacci loop with a maximum of 1,000. Nachi. There we go. We'll save it. We'll run it. Oh, that's not right. What's going on here? Plus equals, not equals plus. Let's try running it again. There we go. So 0, 1, 1, 2, 3, 5, 8, 13, and so on and so forth. That looks correct. I don't like that it is printing the press enter to continue on the same line, though. So let's print a new line after it's done. And that looks better. Okay. Now that we've printed the Fibonacci sequence using a loop, we did that in about 9 lines, but we can do it better. we're going to try doing this using recursion. So let's create another method. And this is our recursion method. Rather than having current and next be something that is set within the function, we're actually going to take them in now. So cur, next, and obviously we need our maximum value. The first thing we'll do is we'll just print out our current. So it's going to be cout cur, followed by a space, just like we do in our loop for the other method. And because we are using recursion rather than looping, we will now just call the method again. So this time, when we call it, current isn't going to be current, it's actually going to be the next one. So we'll pass in next as the first argument, which once again will be current. And our next, when we call this, is going to be current plus next. Obviously our maximum is going to be the same, because that's the number that we don't want to go over. So let's save that. We will copy this and change it to our needs. Start with 0 and 1, just like we do in the other version of this. And then, just like we already do, we'll print a new line at the end of it. So let's try this now. That is a lot of output. Yeah, and it overflowed. Okay, so what happened here? Well, just like you can have an infinite loop, you can accidentally set infinite recursion as well. We don't have any checks to make sure the recursion stops. Let's add them now, though. Obviously, if our current value is less than the max, we want to continue. So let's say if our cur is less than max, but that isn't right, because if the current is 987 and the next is higher than that, it will print out the 987 and then call this method regardless. So we actually want this to be next rather than current. Let's try this now. There we go. So first we have our Fibonacci loop, which is 0, 1, 1, all the way up to 987. And then we have our recursion version, which prints the same thing. But if you look, we're using less code. And we also are using less variables. This is considered, generally this is considered better. And like most tools, a lot of people who first learn about recursion will overuse it. But generally, if you can make something do recursion rather than looping, for a broad concept like the Fibonacci sequence, then it's going to be better to write it that way. It's just making the computer do more of the task purely, rather than having it do secondary work in order to complete that task. Now, with recursion, let's get into the behavior of it. And the way we're going to do that is we are also going to want to print the Fibonacci sequence backwards, starting from the maximum number that we last printed. So in this case, if we continue with 1000 being the absolute maximum that we can print, then the backwards Fibonacci sequence is going to start with 987. With our loop, we're going to start with our loop first, of course. We will cout our end line. And then we'll get into our loop. And that's just so that we can separate the two. So while our current is greater than 0, we will set our temp to current. We will set our current equal to our next minus our current, and then set our next to our temporary variable. We'll also see out our current, followed by a space. Now, previously, we had done our cout statement before we did any math. We're doing it after we do our math for that exact reason. When we print this the last time, we actually set our current value up one value, but don't print it during that last loop. We need to reverse that in order to get the number that we want in our loop. So let's try this now. We'll save it and we'll run it. Okay, let's run through this again because of the mistake I just made. So we have our temporary value. That is equal to our current value, which is the minimum between current and next. We then set our current value equal to next minus current, which is the difference between our upper value and our lower value. And then we set our current value equal to next. Then we set our next value equal to our temporary value. Okay, let's try that. There we go. So we start with 0, 1, 1, 2, 3, 5, all the way up to 987. And then when we go through a second time, we print it in reverse. So from 987 to 610, 377, all the way to 2110. And then we haven't implemented the reverse within our Fibonacci recursion version. So let's do that now. Well, we can think of recursion as something that is layered in principle. When you call something, you go deeper one layer. And when you return from that, you go up a layer. So each call goes down a layer, each return from a call goes up a layer. And if we think about it that way, we are going all the way down our recursion as we print each number, and then we go all the way back up. That means that all we need to do in order to reverse the print is see out our current with a space. And we need our end line as well. So if our next is greater than that, we'll print an end line and then print the current value. Let's try running that. Okay, so we print our loop first, then our reverse loop, and then in this one, we print our recursion, and then reverse print our recursion. But we were able to see that we go into the recursion. This is where the recursion happens. Oop. This is where the recursion happens, is where it calls itself. And then we can actually do things after the recursion as well. You don't have to do it the first thing or the last thing within a method. We've also covered what happens if you accidentally go into infinite recursion. That is referred to as a stack overflow. And there are a whole bunch of other things that recursion can be used for. For instance, if you're given a list of items, you can use it to search through those items, assuming those items have already been ordered. So go ahead and practice this, and good luck on your future projects.